The previous session contained a short introduction. In this presentation, I want to give you a hands-on demonstration. Let me open the Data Management portal. After logging in, the inventory summary is displayed. In order to keep the training simple and clear, I've populated the database with a small amount of data. There is a WebSphere cell with some servers and deployed J2E applications, and JBoss servers with some applications as well. You can see many different computers. Some of them are part of a virtualized environment. There are also DB2 databases and web servers and many other components. Representing the business owner, I know that some of these components are part of my business application. The business application consists of a J2E application running on WebSphere application server, supported by the computer system. It uses a database and is accessible by a website running on IBM HTTP server. Right now, I will focus on composing a business application. To do this, I need to open the Discovery panel. As you can see, there is no Grouping Composer pane that was present in the previous version of TADDM. Instead, we have the Grouping Patterns pane that will have all available grouping patterns. Here we see some example grouping patterns, but we will not use them. Instead, we'll create our own grouping pattern from scratch. We click New. My business application is called eDayTrader. We need to specify a pattern type. There are three options: business application, access collection, and collection. Except for descriptive purposes, one type has a special designation. It is access collection, which is used in data level security mode. Okay, we'll choose the first one. Next, we can choose a schedule determining the time of the business application generation. Schedules can be created from the command line interface tool BizAppCLI. Here, besides the default one, we have three more predefined schedules. Let's choose every Saturday night. You can also change the configuration by using the BizAppCLI tool. It allows you to change advanced aspects of the business application you are building. We will leave the default one here. Okay, let's also provide some descriptive information, such as eDayTrader application and URL, which I will add later. Grouping patterns consist of a couple of elements like name and pattern type that we have already provided. It also consists of selectors. Each selector contains information about how to select core CIs, which are starting points to build the specific business application. Each selector also contains the transversal pattern of dependent objects. Therefore, a grouping pattern is a container of selectors that together build a specific business application or a set of business applications. What's more, one selector can produce subparts of the same type for many different business applications. For example, one selector could produce the subpart containing a database and its instance for different specific databases used in different business applications. Let's see how it looks. We have to specify a name for the selector and provide common component items, which are start elements to build our business application. Also, we have to specify a group name expression, which is a name generator that generates the name for our composition. By default, it will take grouping pattern name. We also have to specify a data transversal template option, which describes how relations with other CIs should be traversed while building the business application. During the presentation, I will explain these elements more thoroughly. Let me start the process of creating my business application by dealing with a J2E application that is deployed on my WebSphere server. I will call it eDayTrader, and I'll add a similar statement in the description. Now I need to add my J2E application as a core component item. I'll click Choose. Notice that I can do it in three different ways: using an MQL query, using an SQL query, or using an instance-based selector by using drag and drop. And in this instance, I will choose the easiest option, instance-based selectors. And we'll go from inventory summary to app servers to WebSphere, since my application is deployed on a WebSphere server. Here you can choose the server itself or use a new option that allows you to go deeper and to see all J2E applications deployed on this WebSphere server. From here, I will choose the eDayTrader application and add it to my selector. This will result in creating a business application called eDayTrader with eDayTrader J2E application as its core CI and some other supporting CIs. To visualize the outcome of my settings, I can click Test. At the bottom, you can notice that my business application will take the name eDayTrader and also will contain core CI item of type J2E application. I click OK to finish. Here we can see a selector including name, description, a core component item, and a name expression used for generating a name out of this pattern. For each selector, you can decide which dependent objects to traverse. First, choose whether you want to traverse dependencies down, lower down, or traverse dependencies up, higher up. When you select lower down, the BizApps agent traverses all objects on which a core CI depends, and all other objects on which these dependent objects depend. For example, the BizApps agent traverses from the web server to a hosting computer system on which the web server depends, and then goes from the computer system to a hosting hypervisor on which the computer system depends. When you select higher up, the BizApps agent traverses all objects which depend on a core CI and all other objects that depend on these objects. For example, the BizApps agent traverses from a hypervisor to all computer systems that are hosted on it, and then to all application servers that are hosted on these computer systems. With these two options, you can traverse relations in only strictly defined directions, either up or down. However, when you move up one level or down one level from the core CI, you can also include processing relations in the opposite direction. For example, BizApps agents can start from a computer system, go down to its hosting hypervisor, and then go up to all hosted virtual computer systems. To enable processing of relations in the opposite direction, use higher down and lower up. You can select higher down only when the higher up option is selected. When you select higher down, the BizApps agent goes down from all objects that it encounters while it traverses the dependencies up. You can only select lower up when the lower down option is selected. When you select the lower down option, the BizApps agent goes up from all objects that it encounters while it traverses the dependencies down. I'll select higher down and lower up only for our business application, just to traverse up and down from the core CI. Alright, click Next and Finish. Now we can see the results of my actions, a grouping pattern with the name of eDayTrader, type Business Application, and a description. Notice that we also have an action to activate or deactivate the pattern. Deactivation means that our processing engine will not take this grouping pattern into consideration. We can also see the last execution and next execution columns here. Notice the next execution value results from a chosen schedule, and here we have 10 p.m. on Saturday night. We also see the execution status, which is now empty because our grouping pattern is idle, waiting for its scheduled time. In summary, a pattern has been created that should result in creating a business application. Now we have to process the pattern in order to generate our business application. We do not have to wait until the scheduled time in order to process our grouping pattern. We can execute it manually by selecting it and clicking Execute. Okay, now refresh the view. Note that the execution status has changed to the value in progress. I'll wait a while for the pattern to have been processed. Refresh again. Note that the execution status is empty and that the last execution time has changed to the current one. This means that the process is finished and the business application has been generated. Alright, let's find our business application. In the Discovered Components panel, we choose Groups, then Business Application, and we can see that the business application named eDayTrader was created. To see the results, I'll select it and click Action, Show Topology. Alright, topology was created, and I'll expand it to make the picture bigger. What we see here is that we added our core component, item eDayTrader application, that is on top of our business application. We can see that it runs on a WebSphere server, and the WebSphere server runs on a Windows computer. We can also see other parts of the WebSphere environment, the WebSphere node, the WebSphere cluster, and the WebSphere cell. And up here, we see a deployment manager with its own WebSphere node. And next we can see a DB2 instance because the WebSphere cluster has the data source parameter set to DB2 database. We can also see that all computer systems run on a virtualized environment and that the virtualized environment is supported by a storage subsystem. In summary, the business application has a new type of topology view. All elements in the business application topology are aligned according to dependency directions between objects. The objects located above objects in the topology are always dependent on the lower objects. For example, an application server is always located above a hosting computer system, which means the application server depends on the computer system. The direction of a relation that connects these two CIs is represented on the topology by an arrow that points from the application server to the computer system. I started with just one element, which is the DayTrader J2E application, and as a result I've brought the whole business application that not only has the J2E application but also an application server, a cluster, a node, a cell, the computer systems they run on, and a connection to a database instance. But in order to demonstrate additional business application capabilities, the data was prepared to not contain all relations, causing two business application parts to still be missing. They are a DB2 database and a web server. I will now reconfigure the grouping pattern to add missing elements. I will edit the grouping pattern to add the missing DB2 database. I will create a new selector for the DB2 database used by the eDayTrader application. I will call it eDayTrader database. Now let's add the database. Let's do it similarly to the J2E application by choosing instance-based type. To locate the database our application is using, we choose Inventory Summary, Database Servers, DB2, expand our instance, Databases, and we choose our database. I will not change the grouping name expression. It is important that it generates the same name as the previous selector. Because it is the same, we can be sure that compositions created from these two selectors will merge into one business application. So I'll just accept the changes. Alright, let's regenerate the business application with the latest changes. Select our execute. Alright, we'll let it process and then refresh. Process some more and refresh. Until it's done. Alright, because we have previously displayed a generated eDayTrader business application topology, it will already be visible in the topology view. Now you can see that our business application contains a database that is used by the application linked to its DB2 instance. What is still missing at this point is a connection between the J2E application and the database. Also, there is no web server yet. So at this point, I'll add this data to the business application, presenting at the same time how the business application is able to adapt to those changes. To do this, I will also assume that because of a database failure, we were forced to switch the database that our application is using. When making these modifications, I will use the Other Creation option to create a business application from separate sources. That is, instead of creating many selectors, I'll create a manual dependency between the J2E application and the DB2 database. Also, one between the J2E application and the web server. To make this easier, let's add the J2E application to the cart. Alright, let's now open the cart and select our application and show dependencies. I'll start with the web server dependency. I select New, keep Provider, and then go down through and locate my web server. And here we select our host and click OK to confirm. Here you can see that we have a connection between the web container of your web server and the J2E application server. Now, to create the connection between the J2E application and the DB2 database, we go back to New, but this time, because the J2E application depends upon the DB2 database, we will select Dependent, and then we need to locate our database. We'll go down through Database Servers, DB2, then we expand the desired instance into Databases, and then here we select the database that we want and choose OK to confirm. With the two dependencies created, we click Close to accept those changes. Now that we have the dependency between the eDayTrader application and the database, we do not need the additional selector for the DB2 database that we created before. When editing the application, we can decide to delete the selector or simply select the disabled checkbox next to it. Let's also enhance the transversal template of our enabled selector. We want the application to go up from the J2E application to the web server virtual host, and then to go down to the web server and the computer system. That's why we need to select the higher down option. That's it, and we select OK to save changes. Okay, I've re-executed the grouping pattern and refreshed the topology. Now you can see that our eTrader J2E application is connected to the new database and that the old database is gone. You can also see that the web server virtual host is connected to eDayTrader. You can also see that all the supporting architecture for the web server virtual host was added, including the web server and the computer system it runs on. In this presentation, we have seen how to define a grouping pattern and how to create a simple J2E application-based business application. We were able to see how dependent components are automatically included into business applications based on dependency data that is stored by TADDM. We saw that when a grouping name expression generates the same business application name, the results are merged into one business application. Moreover, we saw how to add manual dependencies between components and how the business application engine automatically sees them and expands the business application with new elements connected by the dependencies. This concludes this presentation. In the next presentation, we'll show you how to create advanced generic grouping patterns able to generate many different business applications based on MQL queries and enhanced grouping name expressions. Thank you for your time.